Welcome to this video on DC circuits, problems and solutions, focusing on the combination of series and parallel circuits. Let's analyze a combined series and parallel circuit. We have a 12.0 volt source in series with R1, which connects to R2 and R3 in parallel. We need to find the voltages and currents across these components and show all steps. The solution involves 4 steps. First, combine R2 and R3 in parallel to get R23, approximately 4.105 ohms. Next, add R1 in series for the total equivalent resistance, 5.105 ohms. Then, find the total current, I1, which is 2.35 A. Finally, back substitute to find the voltages and currents for R1, R2, and R3. Remember to combine parallel components first, and that the voltage across parallel branches is the same. Now let's look at a series circuit analysis problem. We have an 18.00 volt source connected to R1, R2, and R3 in series. We will find the equivalent resistance, current, potential drop, and power dissipated for each resistor, plus the power supplied by the battery. In a series circuit, the current is the same everywhere. To solve this, first, calculate the equivalent resistance, which is the sum of the resistors, 9.00 ohms. Then, find the total current, 2.00 A, which is the same through all resistors. Next, calculate the voltage drop and power dissipated for each resistor. Finally, find the power supplied by the battery, 36.0 W. Check your answers using Kirchhoff's laws.